All right, we're live. So hello everyone, my name is Kent C. Dodds and I am here with Christoph, and we're going to talk about this testing framework called Jest that has taken the world by storm. At least it's taken my world by storm in just this last week, since I just started using it just a week ago, and it's like really impressive stuff. And so yeah, Christoph, do you want to introduce yourself? I don't know how to pronounce your last name, so maybe you can
It's
say your name too.
Poyer. It's an Austrian name. Anyway, I'm Christoph. I work on JS at Facebook, and I've been around for about 5 years, and I've always kind of I've done an internship like 5 years ago, and I worked on testing a little bit. So I've always kind of had a sweet spot for testing. But about a year ago, I started working on Jest because we didn't really maintain it, and pretty much for every piece of infra, if you don't maintain it actively at a big company like Facebook, at some point it's just going to become slow and not very good. And what we noticed is that when the test infra isn't very good, people just naturally test. And we kind of wanted to counter that and make sure that it's in a really good state so people can write more tests again and for the last year.
Yeah, that totally makes sense. I know that especially when I got started in the community or like in the industry, and I didn't know how to do like anything. Testing was the last thing on my mind. Like somebody would show me how to do it, but it seemed like really complicated and stuff. So I think lowering the barrier to like creating new tests is really important thing to do. Really
Yeah,
helpful.
and I also want to thank you and everyone who's giving Jest like a second chance, because we kind of just stopped working on it, and we open sourced it, and it has worked really well for Facebook. Like the auto mocking feature, for example, that's when by default you just get like a stub or a mock module of everything, and you have to explicitly say, this is what I want to test. That's really good if you have a large code base where there are no existing tests. But it's not really helpful if you haven't written tests before as like a beginner, or if you're trying to test a library and all that. So the way we used Jest internally wasn't really reflecting how people in the community wanted to use it. So we kind of figured, let's just move towards that while still keeping all those things that we need at Facebook inside of it, and make sure that neither of those configurations, either external or internal, is going to slow down the other. So we're trying to find the right balance there.
Yeah, I think that's great that you're doing that, because like it really, I don't know, like it seems like it wouldn't necessarily be in Facebook's best interest to really consider the community necessarily. It's just like, you know, we're building this tool for us, and if it's useful to the community, then that's great. If it's not, then like too bad.
Right.
But it's cool that Facebook's giving you time to do that.
Yeah, so the way I see it is that it's really useful and valuable to Facebook. And all of this work that I'm doing for Facebook, it can be implicitly open source, right? Because we have an open source repo, so we just put all the code in there. So that way it just automatically is good for both. And we just have to tweak like the defaults a little bit that we use in open source, and then everyone can just use it. Another thing I want to point out, and that one is quite funny if you think about it, is that in open source, people were always saying, oh, Jest is really hard to set up and to configure and all that. And this is something that's really hard for us to understand at Facebook, because there's only like 1 or 2 or 3 people working on like this framework, like or different frameworks like Relay or React or whatever. And those people, they maintain it and they set everything up so that people who work on products, they can just go in and write a unit test or use React or use Relay. You know, no one has to install it or do anything. So traditionally, it's been really hard for some of our tools to have like a really good beginner workflow. And for Jest, we were just like thinking, okay, let's just figure out how we can get the best defaults that just work for most people out of the box, and that's I'm pretty happy that it's working well right now.
Yeah, that's awesome. I think that's awesome. Like, I think. Oh, whoops! I'm getting some feedback from you, Christoph. If you want to mute, you can hit Command D, and that will toggle mute for you. Sometimes this happens in Hangouts, but yeah, I think that. Like some of those good defaults are the key to making it really easy to set up. So like I remember, I don't remember what the setup experience was like when I used Jest a year and a half ago. But I remember that it was just like really slow, and I was used to Mocha, which is pretty darn fast. So can you talk a little little bit. I do want to actually, I want to talk about the defaults eventually, but could you talk about the performance side of things and how that's improved?
Yeah, so Jest does a lot of work up front that other test runners might not do. One of the things, if you've ever looked at Relay or React source code, you find this weird add provides module thing on the top of every file, and every file has this like name that's globally unique, and we call this haste modules. That's just a kind of system we invented at Facebook like 7 or 8 years ago. It's really old, but the idea was if every module is just global, it doesn't matter where they are in the file system, and you can require them from anywhere. And it's really good for enabling product engineers to move fast. But then infra people, they always have to figure out what's the best way to implement those systems to not make it slow down all the tools. And Just needs to understand that, for example. We actually need to parse and crawl the entire file system, figure out what JS files we should look at, read them, extract some metadata. And we also, for building a dependency graph, when you run Jest in this mode where you only want to run tests related to changed files, then we actually need to build an inverse dependency graph. And for that, we need to like know the entire file system. And the problem was that we had this system haste basically implemented, but we didn't really maintain it. And then node modules came, and we didn't really take care of that at all. And we were just, every time you started up Jest, we crawl all of your node modules, and you might have like 600 dependencies, and then that takes like 10 seconds and all that kind of stuff. So there were a lot of inefficiencies there, and there's a bunch of tools we built at Facebook like Watchman, which is really cool. It can basically crawl the file system and give you all the files, but then gives you this state basically of like when you last queried the file system. And then the next time you just ask it, what has changed in the file system since then? And then you basically only do this like minimal amount of work necessary to build up this module map and the dependency graph. So we just added a bunch of this stuff, and now the startup time for Jest anywhere is less than a second. So we're pretty happy with that.
Yeah, actually, I want to talk about that reverse dependency graph too, because I think that's one of the really cool things about Jest. So, can you actually talk about why the graph is so valuable on big code bases? Like, so you already talked about how like before you were parsing the entire like AST of every node module directory, like all whatever you were doing with all those node modules, and now you don't do that. But like, let's say I actually do have thousands of files, maybe millions of files in my project. What are some of the optimizations, or can you maybe explain go a little bit deeper on the reverse dependency graph that makes it so I don't have to wait forever for my tests to start running on such a huge code base or test base?
Right, yeah, so that's what I meant with like rewriting this haste system that we had in Jest. We had like a different JS implementation. We had another one in React Native's packager. And then I took both of them and just picked out the best pieces and then rewrote the whole thing to be performant. But yeah, as said, we need to actually parse every single JS file. We don't actually create the AST, we just like look at requires and imports using regex, because imports are static anyway, and for requires it's usually good enough as well. But to do that, we actually do aggressive caching. And one thing that's also pretty cool, we realized in Jest at Facebook, we only run it in this mode. Like when you make a change, we only run the minimal amount of tests locally before this goes to code review, where we run all the tests. So that way engineers don't need to wait for that much time. So what we did here is that extract those dependencies and put them in a cache. And then we can just like do the reverse lookup really quickly. One of the things, yeah, as I said, Watchman really helps with that, so we don't need to crawl the file system all the time. But what we realized, before we can do anything in Jest, before we can figure out this reverse dependency tree, we actually need to do this parsing. So normally in nodes, when you build something in Node.js, everything is by default async, and you take that as a given, right? Everything should be async, and that's great. But then when you have this short-lived command that you invoke, and then you kill it, and then you invoke it again, and you always wait for something to happen, and you cannot do anything else anyway, you have to like parse all this stuff or read it from the cache. We realized when you make all those operations synchronous, that actually speeds everything up a lot. And then the way we parallelize, so let's say we have like 50,000 JavaScript files. we need to read all of them immediately or as fast as we can. The way we parallelize is we actually create worker processes. So we do the main process for the way it sees it is all these workers do this async work of reading from the file system, but then the workers itself, they're synchronous. And that is actually like 30 or 40% faster in just reading all those files. And that was pretty nice. But also because of all this caching and diffing we kind of do in this haste map thing, it's just really fast, and it never does more work than it really needs to. It depends on how much changes in the file system, and most of the time you don't change 50,000 files, right? You only change 5 or 10 of them. So that should, keep staying fast.
Yeah. So and that's mostly for like the development time stuff. But I'm going to be sending this to Jenkins, which is like a slow machine. Can it be fast on like a CI server as well?
Right. It really depends on what the CI server, what kind of machine that is. If it has like an SSD with fast file system access, it's never going to be an issue. But yeah, we do sometimes notice on Travis that we had some timeouts because Jests are written also in Jest. And then they kind of like, there's like this kind of inception kind of thing where we create like instances and read the file system inside of Jest and all this kind of stuff. And we noticed some timeouts there, but most of the time it's fine. And most it's not like super resource heavy. And I feel like if you have this gigantic code base, most of the time you have your own CI system at that point as well, and you have like some control over that.
Yeah, that's a good point. So what are some of the other like features about Jest that you like in particular? What are some of the things that like stand out to you as the author? Yeah. Or not, like the maintainer, I guess.
Right. So this performance stuff, right? That's like exciting to work on, I guess, if you want those technical challenges. But it's not really important to the user, right? The user cares, is this fast or not? If it's not fast, they're not going to use it. So you need to get that in a good state, and that's what we worked on over the last year, and a bunch of other core infra. But those are not the exciting features. I think one of the really cool things now is the new watch mode. That's like very interactive. It like kind of sucks you in. You're like just stuck in this, and you're like, man, this is so cool. I just want to run tests all the time now,
Yeah, that's totally been my experience, man. That's awesome.
And we also added Jest now to create React app. Dan Abramov, I really want to give him a shout out. He has really helped us to polish a bunch of stuff in Jest. And he came up with a bunch of ideas. That was really great. And the watch mode is actually the default there now. So we'll see how that works out, and we might just make it like the real default for when you just invoke Jest normally. We'll see over time.
Yeah, I know in React or Create React App, they like do some special stuff with the CI environment variable, and if you are on CI, then we aren't going to run into watch mode. So that was kind of interesting. I feel like that might be a little surprising, but yeah, that like we can change the norms. There's nothing wrong with that.
Two other things, if you don't mind, that I would like to point out. So one thing, the watch mode, yeah, it seems really cool, but that was like a hackathon project. I did that like overnight. I was like, man, wouldn't it be cool, and that was, it turned out like kind of nice, but it's not as awesome yet. The thing is that this was like a short thing we kind of tried to build, and it worked out really well. But two other things that I think are really important are coverage support, because that was a really long, challenging task to polish it. We had coverage support before, but it didn't work so well. And Dmitry Abramov, he worked on it for like a month or so to make it really solid. And you just invoke it by -- coverage. It's just working out of the box. You don't need to do any setup. So Dmitry did a great job on that. And then also the new matcher assertion failure messages. That's also something Dmitry really pushed for really hard. And we spent a lot of time thinking about what the ideal messages should be like. And I feel like we ended up in a really good state. And all of those things combined is that some of those tasks that we work on, they're really small. You do them overnight or over the course of a day. And some of them take like a month. But it's really this whole package at the end, that makes this really solid. It's not any one change that someone hacked on for a week or for a month or whatever. It's all of those combined that I feel like makes this a really good experience.
Yeah, and one thing that I really like about Jest is that it just, like you said, to add coverage support, it's just -- coverage. Like it couldn't be simpler. And having worked with a lot of different testing tools and coverage tools, like I've given at least 3 trainings on code coverage with ES6 and JavaScript, and like every single one of them used a different tool. Like just with the how things have evolved, and like you had Istanbul, and then you had Sparta, and then you had NYC, and now we have just Jest. And like for all of those, Jest was by far the simplest to configure, and it just like worked out of the box. I was really impressed by that. And like just kind of in general, there are just a handful of conventions that you should follow with Jest, and then outside of that, there's like very little things you need to worry about or think about when you're writing tests with Jest, which I think is a really awesome feature of the tool.
Yeah, I just want to go back to saying that when the tool isn't really working well or hard to set up, people just don't write tests, and that's something we've definitely seen at Facebook. And I also want to mention this work on coverage again, because yeah, we had this support in it, but then that was all from before Babel. You know, like there was no big tool chains or like compilers or anything in JavaScript back then, so it was really messy. And if you work on a project for a long time, it's sometimes hard to see how messed up some things are, and you get this Stockholm syndrome, you know, like where someone takes you captive and then you start liking your captures. And that's like kind of what happens with like open source projects sometimes. So Dimitri came in, he helped me out on Jest a couple months full time actually, even though he works on ads, because it's really important to the ads org at Facebook to also have good test frameworks. So he came in and he was like, wow, this coverage stuff, this really sucks, you know. And I was like, what are you talking about, you know? And then he just like pushed for working on it, and he did an amazing job. So I'm really excited about that.
Thank you, Dimitri. Yeah, it's the work was a success because it's really great. So let's talk about snapshot testing, because I think a lot of people are intrigued by this feature, but like me, when you first hear about it, you're like, maybe you don't totally understand what it even is, or if you understand what it's doing, like whether this workflow is like better than the alternatives for testing UIs. So do you want to talk about snapshot testing?
Yeah, sure. So snapshot testing is this really simple system that we built where you basically say, expect that this value matches a snapshot. And the first time you run it, it just captures this value and stores it in a file. And then every subsequent run, it just compares the stored snapshot to that value that is being put into like your expectation, wherever that comes from. It can be any object. It doesn't just work with React components. It works with any string or object or whatever you can serialize. And then if those two don't match up, Jest asks you to either fix your code because it's broken or to update the snapshot. And that's another thing where we just figured out, what can we do to make it low effort to write unit tests, for example, for React components? And we also just noticed that people weren't writing those tests at all. So those components, they were never called. And then we sometimes had this where someone lands a piece of code and then you just load the page and everything's broken, you know? And this kind of stuff really guards for this unexpected change or like something not even being run, you know? You just like make sure that it's being run. And here I also want to point out, because like some people attribute this to me, but this was actually, we have this cool system at Facebook that's called a hack a quarter or hack a month, where if someone is looking to like change teams or wants to try something new, if they have been on a project for a long time, they can just join something else and work on that. And in this case, it was Christian Calesso in the London office who worked with me. We go back to the MooTools days, so it's a really good friend of mine. And he was like, yeah, I'm gonna like work on this snapshot feature. And he built that end to end. And then Ben Alpert, he really helped with the test renderer and React to get that ready. And that's still also being worked on. Team effort. And I feel like it's kind of changing how we write unit tests in some ways, which is exciting.
Yeah, like like I said, I've only been using Jest for a little bit, and it's already changing the way that I think about unit testing UIs or like responses to like HTTP requests, or like pretty much anything that I can serialize. I want to put it in a snapshot just because it makes so much sense to me. Like when I first heard of the snapshot testing, it made me remember Huxley, Huxley, which also came out of Facebook from Pete Hunt. And basically the idea is like you fire up your app, you take a screenshot, like a snapshot of that, saves it to a file, and then like as you're making changes, it'll compare, and if they're different, then it'll it'll let you know and you can update it. And then you see that in the Git diff. And I remember hearing about that on a JavaScript Jabber episode a while ago and thinking like, wow, that just seems like it makes so much sense. Like I want to be able to see the changes. And if there are changes, I want to be able to decide if I'm okay with that change. And yeah, so like this seems like the problem with that is it takes a bit of infrastructure. You have to get things set up in your CI server and stuff like that to make that work, or make sure that people are actually running those tests and that kind of thing. So it just seems like I would expect it to be a little bit more on the flaky side. But with snapshot testing, like with Jest, it's just like it's just like a regular unit test. You write it the same way. Your assertion is you're expecting it to match something, and then just kind of takes care of it for you. To me, it just makes so much sense.
Yeah, I mean, I also think those real screenshot testing systems, they're really valuable, but as you pointed out, they tend to be flaky, hard to set up, and there's so many things that can go wrong, and then it's also really hard to troubleshoot if like something is moved by a few pixels, which like component was that, and I feel like Jest is a really good framework to test JavaScript. Either if that's unit testing or integration testing, that's up to you, but there's value in all those other systems. For snapshot testing specifically, we noticed that, and I feel like that's probably something you or everyone who is watching has done at some point. You try to write a test and you have this object and you try to match it to like a two equal match. Expect this object to equal this like object that you type out, and then most of the time you would console.log it and then like copy it into your test and you're like, okay, this is fine, and we just figured, what can we do to make this easier? We were even thinking of making it so that when you save a snapshot, it actually puts it into the assertion instead of into a separate file, using like some AST manipulation using recast or something. But then we figured that's maybe like a next level thing, and we'll start out with files because that seems easier to maintain for now and less surprising, I guess.
Yeah, you'd probably get people hand modifying those snapshots and stuff.
Yeah.
That'd be difficult. Although you may still get people hand modifying those snapshots. There's an issue open about that too. But no, so I think that's great, and I've used snapshot testing already for one of my CLI projects, and it's really great to see, okay, like the output of this. Like what I used to do is I just have this big giant string, like, and exactly what you were saying, like I would do like console log what the output was. I would copy the output, stick it in my test, and be like, that's that. Every time I had to go update something, I have to do that over again. And yeah, I'm tired of doing that. So I love that snapshot testing makes that easier. So do you want to describe it? Because I wonder, there's probably people who still aren't totally convinced about the snapshot testing thing. Could you talk about what the expected workflow is, as like, let's say there's an existing snapshot for an existing component that I'm writing. What's my workflow if I actually do end up needing to make it an alteration to that component?
Right. So if we look at how people used to test React components, also especially at Facebook, there are these React test utils that we started out with that kind of ship with React. They're a separate package, and then a lot of people, they just didn't even bother writing tests. So that's like the first kind of people that we wanted to get into, pull into writing tests. But then people who did bother to write tests, they would write those really complicated assertions where you have like this rendered component, you make sure there's like this span somewhere deep in, and then like this div, and that it like does something or has this content or whatever. And every time you change your component, you have to actually spend more time fixing your unit test than you actually changing your component, and there's just no joy in any of that. So the way I see it is when you want to test React components, you just type it out. There's no like test-driven development here, right? Because you build your component and you make it look perfectly, and then after that you can go in and write a test for it. So if you do already have a snapshot, you change your component and then you run the test again. Jest will actually just diff the output and say, oh, it looks like you changed this div into a span. Is that really what you wanted to do? And then you can say, okay, yes, let's do it. That's basically it. And then the nice thing is, if you have a lot of snapshots for a lot of components, and then someone goes in and they change this generic button component to actually, like instead of a button, render to a div or whatever, and then all the snapshots are failing, and then you know about it, and then that can guard against those failures. You do have to look at the diffs though. That is really important. You do have to make sure when Jest asks you to either fix your code or to update, you shouldn't always just press, oh, this is fine, you know, I'm going to update. You have to actually check whether that's what you want.
Yeah, and I think like I think it would be okay. You know, I am changing this button, like it needs to be changed, whatever. And so you just update, and then the where like things really come into play, in my opinion, is when you like actually commit that snapshot to your source control and you push that to like a branch and you make a pull request, and you can see that in the diff. And so everybody looking can see, oh, they changed the button and that affected all of these other components.
Yep.
Did you check that all those components look okay? You know, like I just think that's just such an awesome feature.
Yeah, I agree. Testing is really all about signal and like giving signal to people whether what they're doing is right or wrong, or what they could do better, for example. And at Facebook, we all have this thing where when you send out a diff for code review, we actually highlight each individual line in the code review, whether it's covered or not. And we're not like telling people, oh, you have to write tests for this. This is not being covered or whatever. But then when the code reviewer goes in and they see, oh, this seems like a really important function, but then there's this like red line on the side that says this function isn't actually tested, then the code reviewer can use his best judgment and say, okay, he can either comment and say, can you write a test for this? Or he can say, depending on whatever this function is doing, maybe we don't need a test. And it's the same for snapshots as well. Like the code reviewers, they get this picture of what this change actually means, because it doesn't happen that often that someone just takes some code and then patches it and then actually runs it, and they don't have all the context of what that person tried to do most of the time. So there's some disconnect. So any signal we can give to the code reviewers to help review code in a more effective way is really good.
Yeah, I think that's awesome. I'm so looking forward to hopefully convincing my team to let me to migrate so we can get take advantage of that. Because now finally I feel like I've always said, okay, we need to unit test. This is a good thing, but I have been frustrated by like just the things I have to do to make it so that a refactor doesn't break my tests. And I think that snapshot testing will help with that a lot. I've just got a couple minutes left before I have stand up. So do you have anything else that you wanted to chat about with Jest?
Yeah, I mean, I just want to say I'm glad that people are giving us this chance to make a second first impression on the framework. As I said before, the only thing it has in common with what it used to be a year ago is the name. So we rewrote everything, and I know it's not perfect in many ways, and there's still so much that I feel like we can do and that we should do. And so I'm glad we're given this chance and that people start adopting it again, and I hope that we can just make sure that it's awesome for everyone. And so yeah, please just file issues and then let us know what doesn't work for you, and then we can help figure out what's going on.
Cool. I just remembered one other question I wanted to ask. Can you think of any companion tools or anything that like is really awesome the community has built, or something that you can use alongside of Jest? Right.
I mean, you can use most things that exist. Like you can use Chai if you like those assertions better. You can use Enzyme if you prefer Enzyme for DOM testing and all that. The React test renderer is still not entirely finished, and the team is working on that really hard. It's just going to take a little bit longer. So the way I feel it is, I don't really like drama, and people are very religious about unit testing and how to do it. And I don't really care about any of that, and I don't want to deal with any of that. So I just want to make it work for everyone, and then they can do whatever they want with it, basically. So as long as I'm happy to add features to Jest as well, as long as it's not slowing it down and not making it harder to maintain. But I try not to be too opinionated about it, because I understand people have their opinions, and some of them for good reasons, some of them maybe not. But I just want to make sure it works well for like most people, I guess.
Cool.
That's what I can say there.
And having those good defaults is it's just super awesome. The other thing that I just remembered I wanted to mention was, I haven't tried it yet, but there's a tutorial for Webpack integration, and just looking at the tutorial, I'm just like, oh man, this is so much better. Like so there's great integration with Webpack if you're going to use the Karma runner. Like that integration is solid. but there's not very good integration for other test runners like Mocha or Ava. The integration story there is just not stellar. So the tutorial I saw made it look just so clear, and so I'm looking forward to giving that a shot.
Yeah, so the only thing I want to say, it's not like real integration. You wouldn't be using them together. It's more like, this is what your Webpack config might look like, and this is what the same config would look like in Jest. One thing that if I'm entirely right, but the way I understand it is, if you use Webpack for testing, you would build a bundle of your entire app, and then you would run tests with that. And it doesn't do any of that. It looks at individual files, and it like requires visually. So you only like transform the files that you're actually using in a test and all that. So if you're only running 3 out of 1,000 tests, you're not transforming your entire code base, all that kind of stuff. So I feel like that's a good choice that we made, to not directly integrate, but to provide similar kind of configuration options.
Yeah, totally. Cool. So one last thing that I wanted to mention before we wrap up here, and that is, if anybody is watching who hasn't heard of the videos that I've been doing for Egghead.io, then check those out. You can find them at kcd.im/egghead-jest. And I've got 4 videos on there. They're like 5 minutes long each or so, that talk about how to kind of get started with Jest. So hopefully those are helpful. Jest has been helpful to me, so it's the least I can do. So cool. Well, I just got pinged PM. I should probably get into stand-up. Thanks so much, Christoph. This has been great, and I think this is good for the community. So thanks so much for the work that you do.
Yeah, thank you so much for interviewing me. This was a lot of fun.
All right, we'll see you around.
Bye.